Hi, this is Jason, and this is a question 2 from the homework 2. So we can see the question is given the probability x equal to 0 is 0.2, x equal to 1 probability is 0.8, and for all k greater or equal to 1 and less equal to n, they have some conditional probability. And we are trying to find the question 1 is we're trying to find the probability of x2 equal to 1. So basically, we can see we have probability x1 equal to 0 is 0.2, and the probability x1 equal to 1 is 0.8. So here, the two conditions, like we can get x2 equal to 1. So the first condition is given given x1 equal to 0 and we x2 equal to 1 and times probability x1 equal to 0. And second probability is x1 equal to 1 and this condition x2 equal to 1. And then after that, and then like times the probability x1 equal to 1. So we can find like from the question, the probability given here. So when xk equal to 0, when xk equal to 0, and the xk plus 1 equal to 1, give the condition xk equal to 0, xk plus 1 equal to 1, the probability of that is 0.4. So here we use 0.4 and times 0.2 and plus give us a condition x1 equal to 1, x2 equal to 1. So basically we come back to the question here. Xk equal to 1, this is a condition, and this is a given condition, and xk plus 1 equal to 1. The probability of that is 0.7. So here is 0.7 times 0.2 plus 0.7 times 0.8. And the result is 0.64. So we can use the same method to calculate the probability of x2 equal to 0. So we got the probability of x2 equal to 0 is 0.36. So for question B, so we're trying to find the probability of x3 equal to 1. Use a similar process, we can get like the probability x3 equal to 1 is there are two situations like one is when x2 equal to 0 gives this condition, and then we get x3 equal to 1 and times the probability x2 equal to 0 plus x3 gives a condition x2 equal to 1. This condition we have x3 equal to 1 and the probability times the probability x2 equal to 1. So similar, we go back to the question, have the similar probability here. Since given the xk equal to 0 and xk plus 1 equal to 1's probability is 0.4, and similar here, xk equal to 1 gives this condition, and xk plus 1 equal to 1, the probability of that is 0.7. So here we got this equation, and we find this equation and calculate that we got 0.592. And we also see like in this question, we can do it in the matrix. So the probability x equal to 2 and the probability x2 equal to 1 times the matrix, the condition probability matrix. So here is 0.6 0.3, 0.4, 0.7 is this is 1 by 1. So after computer this multiplication, we got 0.408 and 0.592, which this is also similar to the answer we calculated before. Use last method. So basically, we also can think about that, use x1 equal to 0 and x1 equal to 1, and then use multiply twice the matrix. We will get the same results. So here, for question C, for question 3, for question C, we also, our question is given the condition x3 equal to 1, what's the probability of the x1 equal to 0? So basically, the conditional probability equal to probability gives the condition x1 equal to 0 and x3 equal to 1 times the probability x1 equal to 0 divided by the probability x3 equal to 1. So the question here is what's the value of the condition, give the condition x1 equal to 0 and the x3 equal to 1. So if we want to calculate this probability, we can go back to the question 2 like we used here. Give the condition x1 equal to 0 and x3 equal to 1. So basically it's here. So we will calculate the square power to 2. Yeah. So the 0.6, 0.4, 0.30, 0.7, and the result is 0.48, 0.39, 0.52, 0.61. So here, this one is the probability x equal to, given the condition x equal to x1 equal to 0 and x3 equal to 1. It's 0.52. So for here's for the answer of the question, the probability of the condition, given condition x3 equal to 1 and x1 equal to 0 is 0.52, which is we list here, the formula is here, and x1 equal to 0, and the probability of the x3 equal to 1, which we calculated in the last question. So the result is 0.176. For the question 4, so we want to know the limitation of the probability of the xn equal to 0. So similar here. So we, from the last question, we know like we can use the formula, use the x1 equal to 0, x1 equal to 1 times the probability, times the conditional probability matrix. And let's see, like this one is a k number, like what's the k? We want to know x3, just put 3 here. We can get the result of the x3, probability of x3 equal to 0 and x3 equal to 1. So here we want to know the limitation of the when the n approach to infinity. So here we just put the n here going to infinity. So after calculating this, we get the matrix third of 3 and also fourth of 3 and third of 3 and fourth 3, fourth 7, yeah, And we calculated this to multiple 0.2, 0.8 times this matrix, and we got 37 and the 47. So basically, we got the limitation of the xn equal to 0 is 37.